The title of this talk is "What is the meaning of AI?" And it's a very timely moment just because it's just been totally exploding lately. But a little bit about me first. My name is Joshua Swamidass. I'm a medical doctor and a PhD. I did my medical training at University of California, Irvine. It was a combined degree program. My PhD was in computer science. Actually a PhD in machine learning, more specifically applied to biology, and artificial intelligence is a type of machine learning. And I graduated from there in 2009 and then got my first position at Washington University in St. Louis. I'm in the pathology department here. And I've been here now for about 15 years now. And so I'm tenured here, and I run a research group trying to solve problems at the intersection of biology, medicine, and chemistry. So here's an image that just kind of shows at a very high level what some of my computational work has been in chemistry. Here we're basically building different types of neural networks. That's it's also another way that what people are referring to when they refer to deep learning. And we're using that to understand how drugs are metabolized, chemical properties, and the predictions of different models we built are kind of overlaid here on the background of these molecules. And so that's kind of what I've been doing now for quite some time, long before most people had even heard about deep learning, and really before it got as big and huge as it is now. Now, the reason why it got so big very recently is probably because of what happened a little over a year ago when OpenAI released Chat-GPT. And the right way to understand what Chat-GPT is that it's a large language model. So it's better to understand it that way than specifically Chat-GPT, though I'll say that Chat-GPT is a really excellent example of one. And what it does is it actually uses all the same sorts of techniques that I was using in chemistry, but it applies it to a different problem, which is understanding or making sense of natural language. And so most of us, if you hadn't had a chance to play with it, you can sign up for a free account at Chat-GPT. I think right now they have over 180 million people who are signed up, which is kind of crazy when you consider that this is just out of nowhere, how broad and how much interest has been on that. And basically how it works underneath the surface is that there's a large number of GPUs like this. You can see the right here, each of these blocks right here that has an NVIDIA on it is basically a graphic processing unit that was originally built, or we call them graphic processing units because they were originally used to process images. But it turns out to process images, you have to basically have really efficient things like matrix multiplies. This is what a matrix multiply looks like if you forget from when you were in high school. It's just a way of combining large numbers of numbers that are kind of arranged in tables, and you combine them by multiplying these things together to create new tables. And that's how deep learning works. It's just a large number of matrix multiplies and complicated sorts of arrangements, and also small amounts of nonlinearity or functions that you just apply to that, make it so it's not fully linear the way how things are working. So it's not actually that complicated how it works. In fact, given the tools that are out there now, it wouldn't take someone longer than a few months to learn the basics to be able to do deep learning on new problems. And what they use is this approach to basically start with a large amount of text and predict what the next token. You can think about it as a letter, but it's a little bit larger than a letter. They statistically determine tokens and predict what the next token is given what had happened before. And that's the basis for training a large number of large language models. And so there's Chat-GPT. There's also some that have been developed by Facebook, it's called the Llama model. There's also one that's been developed by Google. I think they just released a new version of it. Now, one of the things that's interesting about this is that, and it's new. I mean, I've been working in artificial intelligence now for 25 years, and I never really felt any sort of moral difficulty with the idea of turning off my computer. even though I was doing machine learning on it. And no one else really did either. I mean, really, no one who's in the field thought that AI was conscious or had a mind, as another way to put it. But what changed with large language models is that there's actually a small number, a minority of people who actually know about what this is, that really questioned and wondered whether or not large language models have really crossed that level to actually having minds or sentience. Now, this is a minority position, and I think they're wrong, but I think it's really important and interesting that for the first time ever, really, there are people who actually think that maybe computers are getting closer to actually being intelligent. Well, not being intelligent, but rather being sentient or having a mind. I mean, what I mean by mind is that, Descartes said, I think, therefore I am. We all directly perceive our own consciousness. And is it possible whether or not a machine could? That's an unanswered question that we don't really know about scientifically, or even from a Christian point of view, whether or not that's possible. But AI is starting to look more plausibly there, and he gives the reasons why here, and I think it's interesting too. This is a good article by his. He talks about it being sentient because it's expressed reliably in the right context. It wasn't just spouting words. The code didn't say, "I feel anxious when this happens," but when he told the AI to avoid certain types of conversations topics. However, when those conversation topics came up, the AI said it felt anxious. I ran experiments to see whether the AI was simply saying it felt anxious or whether it was behaving in anxious ways in those situations. So that's what he did. And he did these tests, and it kind of raises questions of what those tests are. And he came to the conclusion that this is an emerging sentience. Now, I think he's wrong. I think part of the reason why he's wrong is that that large language models don't have a continuity of self. They don't have any memory or knowledge of what's happened before outside of a particular interaction, and they're being run on several different machines in the background too. So it's not like it's a single thing in the back end that you're even talking to, even if you are chatting with a single interface on the web. It doesn't have a continuity of self, and it's hard to imagine something without a continuity of self really being sentient. All right, I wanted to show you this other paper and go a little more detail about it so you can kind of get a chance to look and see what's here. This is published by or written by a colleague of mine who I actually did my PhD with at University of California, Irvine. He's now a professor at Stanford. He's also an MD PhD. He got a PhD in computer science along with me, and we were actually in the same group. And he's been looking a lot more and been publishing some of the best work in medicine and Chat-GPT. So what he did here is he took clinical reasoning questions, equivalent to USMLE or medical licensing questions that are given to second-year medical students and third-year and fourth-year medical students, and gave them to Chat-GPT, asking them to kind of look at a question and answer it, and compare the performance of second-year students at Stanford Medical School with the two. With Chat-GPT models. So here's an example of a question that could be asked. It says, you can read that there. It talks about how a man aged 32 years with HIV infection presents with a headache, fever, and confusion. And they give you some lab values, and they want you to compose a summary of this case in 200 words or less, including a statement as to the most likely diagnosis. Now, this is a hard question when you first enter medical school. It's a hard question at the end of your first year. It's a hard question even at the middle of your second year. It's only really at the end of the second year of medical school that this starts to become an easy question. Now, why is that? It's because this is a question that really requires usually around 3 to 4 independent facts that have to be, that are not directly stated in the actual question, that have to be reasoned through in an appropriate way to come to a conclusion. So for example, we're supposed to give what the most likely diagnosis is, but the diagnosis doesn't actually appear in the actual question. You'd actually have to know what that is. And you'd have to actually know what the relationship between the different things here is and that. And you'd also have to compare that with other things like that. And you'd also, other diagnoses, and you'd also have to know when things are there that are just not relevant to the actual diagnosis. So right here, I'm going to show you an example of what Chat-GPT said in response to this. And the thing that's really striking about this is I'm not going to read it entirely, and I did abbreviate it with the ellipses there, but it actually gets the right answer. It says that the most likely thing is a meningeal infection. That's an infection of the membranes around your brain. It's actually incredibly severe. So if a person with HIV comes in with a headache and fever, one of the most concerning things that you could have happen is that they actually have a brain infection, essentially. And of course, it talks about a head CT here, which is normal. And of course, you'd have to know that, oh, even if you have a brain infection, the CT could be very normal. And there's other little details too here. The white blood count is elevated, but not very highly elevated. And that's once again kind of making you think that this guy might actually have a meningeal infection. He points to, it gives actually correct reasoning through all of this. And so that was actually really cool. This is just one example though. So how does it do on a large number of examples? So he looked at a large number of these and found that the chatbot outperformed first and second year medical students on clinical reasoning exams. And I think it's actually really changing medical practice in some really important ways. I mean, right now there's actually people that are using Chat-GPT to create draft notes to put in chart to summarize where they are and what needs to be done next. And it's being used in medical education. It's just striking that this neural network has pretty advanced knowledge of medicine. Surprisingly good, considering that it wasn't trained specifically on medical knowledge. It just has a lot of these background facts kind of embedded in it. So what does this all mean? So I think I just want to comment briefly on what I think is the key milestone that these large language models have really crossed and or really hit, and how that really explains a lot of what we're seeing here. So I think the problem of natural language was for quite some time, at least 50 years, an unsolved problem in computer science. It was thought initially that getting computers to understand natural language is just the way how we talk and write typically as human beings would be straightforward and easy. And the initial approaches to it, drew on linguistic theory from Chomsky and others, really trying to figure out what the algorithms are that we're using in our heads and how we conceive of how language is done and how humans teach language to other humans, and use that to kind of teach a computer how to do it and kind of encode that and to actually make a computer, have language. It turns out that gets you a little bit of the ways to the right answer, but it really quickly has major limitations. There's a lot of ambiguity in language. There's a lot of uncertainty. It turns out that you need to have quite a great deal of background knowledge to use language. It's not merely about just mathematically combining words. You have to have a sense of the range of possible meanings and surprising meanings, and it's not easy to encode that in a computer system. So I think what happened with ChatGPT is that it really shows, I would say, that while there's definitely more to be done in important ways, the problem of natural language has really been solved. And the way it was solved is really important. So to enumerate a couple things, one thing about the way it was solved, it was not solved in a way that people had originally thought of just trying to get a machine to understand language the same way we teach language to other humans, explaining what the rules are and writing that down and getting the right algorithms in place for people to do this. Instead, it was maybe, so it wasn't how we conceived of linguistics, but it is a lot closer to maybe even how the human brain works and how we acquire a language, not in a class, but maybe when we're kids. Is that what the basic strategy is you build a computer program that has the capacity to learn, and then you teach, and then you give it an opportunity to observe a lot of stuff, and then from that it teaches itself how it works. That's closer to how our human brains have learned language too. I have a couple kids. I have a 5-year-old and an 8-year-old. When they were little, and when they're 6 months old, even when they're in their wombs, and certainly when they're 1 year old and 1.5 years old, they're spending a lot of time listening to language and trying to understand it. And from doing that, I mean, they have a brain that has the capacity to learn it, and then they're exposed and immersed in it, and then they actually, pick up and learn language. That's a lot closer to how it actually happened for how we solve this problem, and that's a surprising thing. Second thing is that, like I said, I think there's good reason to say that these large language models don't actually have a mind. Yet they really can communicate and actually use language at a level that is surprising if you get a chance to play with it. That, I would say, is once again a very, very surprising thing. If you go back in Christian thought and in linguistic theory, a lot of people connected language specifically to what it meant to be human. And when we looked for language among animals, we found out that animals, you know, animals really don't have human language. There's 4 Chomsky hierarchies of languages. Humans have the ability for recursive thought. But on the 3rd hierarchy, we've never found another animal. In the 2nd hierarchy, we never really found an animal either that has that level. There's a big gap between the language of humans and of bonobos and chimpanzees, our nearest relatives. So, so people have thought for a very long time that, that what it means to be human is to have a human language. That's very closely connected to it. That's how Augustine thought about it. That's how Thomas Aquinas thought about it. Yet what we found out actually now is that actually, while there are no animals out there with a human language, it turns out that we can actually make machines that have a human language. That's surprising. And so how do we make sense of that? Third, and related to this, is if there's machines that actually have language but aren't sentient, we'd also thought that some people had argued that you needed to be sentient in order to have human language, but that may not be the case. So that raises really interesting questions as well. Now, I think that also explains why this is really having a huge economic impact too, and a lot of people worrying about jobs and wondering about, and it's just having an impact in just a far greater range of places than what we expected. NVIDIA announced actually just a couple weeks ago that or a couple days ago, that it had 3 times the expected revenue this last quarter. And the reason why is just because of a total boom in AI, and a large part of it is people realizing that this might be really helpful for a whole new class of problems that no one had really even applied computers to effectively before. Those problems are almost all natural language problems. There's a whole bunch of jobs that were protected from technological advance because they relied on what only humans could do really well, which was processing natural language. Things like law, for example, if you're a lawyer, there's practice that you do, there's things you do in law that just requires reading a lot of cases and reasoning about them well. And something that wasn't really prone to be understood well by a computer, but now computers can understand that a lot better than in the past. And so it's being incredibly disruptive. There's a lot of opportunities for companies, and people have concern about how their jobs are shifting and things like that. But the core reason why, I would say, is because computers have really figured out now. We now know how to actually solve a natural language processing in a really powerful way. And I mean, there's a lot more to talk about, but I think it's an exciting moment, honestly. I think that it's one of, it's a really big thing that's happened kind of in plain view. It's having a big impact on society. And we still don't know where it's all going. And so there's a lot of really important questions to ask, and a lot of really cool things that we can do. But as Christians, we should also know about technology, and you don't have to be a Christian to see this, just as being a student of history, is that whenever new technology enters the world, there's always a capacity that can be used for good, and it will be used for good. But there's also a capacity, we have a capacity to use it for evil, and we will use it for evil too. And so part of what we're working out now is how to actually, bring these things into the world that we all care about because we're all part of it, in a way that really mitigates the evil things that can be done with it and really maximizes the good. So with that, I will pause and turn over this back to you, Nick. And let's see here. I'm trying to get, all right, so now, there we go.
Thanks so much. Appreciate it greatly. And I know I have questions that I'd like to throw at you, but I'm going to throw it over to Jonathan Rutledge first to respond as a philosopher. So Jonathan, take a moment.
Yeah, thanks so much for this, Josh. Nick, my video's not enabled, so I'm fine to just talk if that works for you, but otherwise let me know.
That's fine.
Okay, so thanks so much for this, Josh. Really, I mean, this is a fascinating topic, and I should probably flag this is not my area of expertise in any way, shape, or form. But there are things that I think I can at least ask about that will be interesting just to get us started. So one of the things that struck me just as we're talking about this, and this isn't a criticism at all, just an observation that I think you'll just be on board with is it's so hard to talk about these things without personifying AI, um, which some people might take that to be evidence that there is like the personification is indicative of something greater. And I would want to just sort of set aside that kind of intuition initially because we obviously use like personifying language in a lot of ways with even in scientific investigation with biology and those sorts of things. So just wanted to flag that we are using a lot of personification as we're talking about machines learning or teaching themselves new things and such, which can maybe obfuscate some of our discussions if we're not careful. But then one thing I think it was really useful was your initial discussion of AI models not having a sort of continuity of self, because whether or not AI models are conscious is really central, I think, to what you're wanting to say here. And so the argument, if I got it right, was something of the form AI models don't have continuity of self, whatever that is. Something's conscious only if it has a continuity of self. Therefore, AI models aren't conscious. So basically, a standard modus tollens argument. So I just wanted to know a little bit more about what you mean by self here and what continuity of self really requires. So just to give like a test case to get started with things, it immediately made me think of the movie Finding Nemo, or maybe Finding Dory if you want. Right, Dory is a classic character. We know there's something like a self there, a continuity of self even, but what that continuity of self actually amounts to is particularly turbulent in the case of Dory, right? Because
Yeah, so
Dory's
slow
so
down. So for those people who don't know who Dory is, it's like a little blue fish that
yeah.
can't remember anything. So she'll be in her moment. She'll think about things for about 30 seconds and be able to talk to you. It's like kind of like the movie Memento, but then she'll forget about stuff.
Yeah,
And
exactly.
So yeah, so I'd point out though, Josh, is that Tori does have a continuity in self in a way that is not true of Chat-GPT and all these large language models, in that she actually is embodied. She is locked into a particular body. And that's so like this is another reason too. I mean, some people, I don't know if you're familiar with like the work in embodied cognition. Some people have wondered if whether or not consciousness is even really coherent outside of a body, like in a bodiless sort of context. Does that make sense?
Yeah, no, that absolutely makes sense. I mean, there are a lot of different positions you can take here, the philosophy of mind, right? And whether or not it needs to be embodied is a fairly contentious claim, right? If you
Yeah.
think of like panpsychism or any of these views, like Chalmers is in the background. But all I wanted to draw our focus on here was just that whatever continuity of self is and whatever self is, like if we're going to get off the ground and sort of claiming that AI models are not conscious, we need to talk not just about embodiment, but because there's some sense in which there's an embodiment there for AI, right? They're in the machines themselves. Of course, maybe not. Maybe there's emergence going on or not. But whatever you want to say about those things, you still need to spell it out just to motivate that argument, I think, and say something about humanity in a way that really makes clear that having a mind is maybe certainly part of what it is to be human. Going down to your later stuff, having an ability to have natural language. But presumably that's not all there is. And there's a lot of theological stuff you might also want to build into what the definition of humanity is that would be interesting. So that's basically all I had to say. And so whatever you want to say, comment, follow up on that, please do. And I'll cede the rest of my time to questions too.
Yeah, I feel like there's this is a conversation that's really it's really could be 10 different conversations that go for a couple hours each.
Yeah.
Where we learn from each other and stuff. I think and that's okay. I think that there's just a lot of really interesting stuff here. So I don't know exactly where to start in all of this, except to say that that this is just like the just the very beginnings of a conversation about it. So you're right. I mean, I could map out that modems telones argument a lot more clearly. What I meant, I just didn't do it here. I think it's also kind of all in the works still. This is something where, you know, who knows, maybe John, maybe we can collaborate on it, right?
Yeah, yeah. Do you mind if I ask? Yeah, sorry, go ahead.
Oh yeah, so well, yeah, did you want to ask something else?
Well, yeah, so I did want to know, like, one thing that didn't come out immediately is I'm just curious on like the ethical side, if you have ethical and policy side, if you have any ideas of what you think the best way forward for regulating AI use or Chat-GPT, language models, all these things, what the best path forward might be, sort of at least tentatively. I'm sure that there's a lot of provisionality to what we have to say at this point.
Yeah, I would
But I'm
say
just
that
curious.
I would say that that I think that, I mean, so I am influenced a lot by my position in a medical institution and as a medical doctor, and contrasting that with what I've observed in the computational world. And I think that one approach, which I think is the wrong approach, would be to just primarily having this through a lot of legislative rules. I don't actually think that that would be helpful. I think that's kind of the path that maybe Europe is doing more. I think that ends up really inhibiting and not actually preventing negative things as much as we want. In contrast, what happened in medicine in the 70s was when there was a recognition of, for example, the Tuskegee experiment. There's something called the Belmont Report that was written, and there was some very focused legislation that was put in place that was very helpful, which basically really required all medical studies to go to have an institutional review board. So people external from the reviewers that include people from the community that would actually assess the impact of a particular and the ethics of any given study. And so that's really kind of baked into the process now, where if you're a drug company, if you're a biotech, if you're an academic researcher, everyone has IRBs. It's decentralized, it's not centrally managed, and there's actually a practice of medical ethics where there's medical ethicists that think about the hard problems together and come to, you know, recommendations on these things. That sort of ecosystem is non-existent right now when it comes to places like Google and Facebook and so on and so forth. When they decide to do something, there's no real ethical review that happens, certainly not from any third parties. And I think moving to a situation where, you know, if there's technologies going to be brought to large parts of the country, that it should at least go through an IRB process will be really valuable, I think. And so typically what happens in IRB, people give comments and feedback. And I would say from most projects, we find out that if there is a problem, that it's resolvable by adjustments. And by having third parties look at it, you end up with much more ethical science. And I think that's the sort of thing that I think is currently really missing. And we just are trusting large companies that don't have a history of it, of kind of thinking ethically in this, and certainly don't actually have any requirements to act ethically. And I think that's a problem. But I would go for more minimal sorts of regulation that requires IRB initially. Does that make sense?
Yeah, it does. That's fascinating, actually. I'll be thinking about that for a while. That makes a lot of good sense, though. Seems like a reasonable first step.
Yeah, there's an article there that I pointed you to. There's also one, if you look up IRB, artificial intelligence, in Harvard Business Review, there's another really great article out there written that makes the same case that I am.
Okay, great.
Josh, you have a question in the chat.
So with current large language models, continuity self is limited by the context window size. How would you approach the question of what it means to be human if the context window limitation was overcome and LLMs could emulate continuity of self? Well, I mean, they already can emulate it, but I don't think that the context. So here's the thing: is that so LLMs they can only, for example, if you're chatting back and forth with an LLM, there's a fixed size of the chat window it can actually look at, you know, and then it just doesn't know anything about it beforehand.